This is the Math 1111, 12 p.m. Zoom meeting for Thursday, November 12th. So we will start working some problems here. Just walk through 4.3 and 4.4, working some problems. 4.3, we'll start with some logarithmic forms to exponential forms. I think we got down to, we'll try the last two here. 4.3, page 387, number 7, last two rows. Under log form, this log of a base 8 of 1 over 8 equals -1. I want you to find exponential form. And that would take 8 to a -1 equals 1/8. So you wind up going 8 raised to this equals this. And finally, this is what was given. If you're given 8 to -2 equals 1 over 64, they want you to find log form. You'd wind up taking log to a base 8, that's the base, of the 1 over 64 equals -2. All right. You're doing the same thing in 9 to 16. You're just, they get a whole bunch of log forms. They want them written in exponential, and then here there are exponential forms. They want them written in log form from 10 on, 17 on rather. All right, let's try 13a. Log base 3 of 5 comes up x, and they want the exponential form. You take 3 to the x, 3 to the x comes up 5. Why don't we try b? A log base 7 of a 3y equals 2. Exponential form. 7 to the second equals 3y. Okay. Let's do the reverse then. Let's try page 388. 388. We try one like 21. 4 to the x equals 70. Part A. Write log form. Base is 4. You would take log base 4 of 70 equals the x, the logarithm. How about B? 21b. 21b. 3 to the 5th equals w. Write in log form. Log base 3 of w equals 5. If you want to see the steps, 3 to the 5th equals w, you'd wind up taking log base 3 of 3 to the 5th equals log base 3 of w. These undo, log base 3 of W equals to 5. Leaves 5, log base 3 of W. After you get the system down, you don't have to write out all the steps. All right, we can go on, and why don't we try one like 31 is pretty simple. 31A, page 388. I want you to evaluate. 3 to a log base 3 of 5. Yes, this would indeed come up 5, because these would cancel. B, 5 to a log base 5 of 27 would indeed equal 27. These cancel. C, to an ln of 10. Yes, would indeed come up 10. Base C, base ln, they're on your calculator on the same key. That's the notation for base C. They undo each other. All right. Further down the page, we want to find X. Page 388. Why don't we try 39, part A. A log base 7 of a 1 over 49 equals X. Well, a log base 7 of 1 over 7 squared would equal X. A log base 7 of 7 to a negative 2 would equal X. And now it looks exactly like the problems up above. Negative 2 equals X. The X would come up negative 2. Since I've shown you 4, 4, if you wanted to check on calculator, have a log base 7 of a 1 over 49, you would punch it as ln of a 1 over 49, ln of a 7. If this doesn't come up negative 2, I'll quit on the spot. ln 1 divided by 49 divided by an ln of 7. It didn't come up negative 2. That is because I have mispunched. Oh, God. Look like an idiot in front of everybody. See those double parentheses? I didn't realize I'd had double. I should have double looked it over. Let's call it back and take out one of those because it's putting the ln of 7 inside an ln. It's all ln of the whole thing. All right, let's try this now. All right, I'm taking an ln of 1 over 49 just by itself, close parentheses there, and divide it by an ln of 7. That's how you punch it to get negative 2. All right, well, if anybody watched that, you discovered I look like an idiot on that problem. All right, let's see. How about one like 43? Got the X as a base. Part A, log of a base X of 16 comes up 4. Well, this is a little more thing you got to undo with base X. X to a log base X of 16 is equal to X to the 4th. These undo, leaving the 16. X to the 4th. If you remember your number, what to a 4th would give you 16. You can tell it have to be 2, but if you really want to punch it, X would be the 4th root of 16. Hopefully you know that's 2. So in effect, the log base 2 of 16 equals 4 for the check. Log base 2 of 16 comes up 4. Again, you could punch it ln of 16 over ln of 2. See if I can punch it right this time. Okay. ln of 2. And there you are. Uh, 45, 47 should be pretty straightforward. They're giving you straight LOG keys and LN keys. How about 48, part A, page 388. Evaluate ln of 27. Again, you have an ln key. Punch it when it shows ln 27. 3.2958. ln of 7.39. 2.0001. And that was part B. C is ln of 54.6. That's almost 4. 4.00003388. You could write 4, it'd be fine. Isn't a whole lot to that. I think we showed you, why don't we do a domain, range, and asymptote. We'll finish this section with a problem 61. 8 g of x, a log base 5 of a minus x. We want a graph, domain, range, asymptote. You'll have to enter this as an ln of a minus x divided by an ln of a 5. And negative x, ln 5. It's going through a -1, going to the y-axis. It goes down forever, even though it can't show you that. And then it's coming up. And there would not be any. I know it's looking flat, like there's an asymptote, but there isn't one. And so there's the graph, y-axis, x-axis. Domain, domain. Along x, you're going from negative infinity coming into 0. Tricky. Range, though, that's going all the way down, negative infinity to infinity. And the asymptote's a vertical asymptote, x equals 0. Not a horizontal asymptote. All right, why don't we charge on to 4.4. And we're using again in 4.4 the laws of logs. I'll just use an ln of AB. Busts up as an ln of A, add an ln of B. Divide them, and it will subtract them. And we punched in some numbers last time to try to verify this. So watch Monday's video if you're dying to see, why this works. And if you have an a to a power and ln of a. So they want you to use all of these. Why don't we try one like 18's a little long. Page 395, 18. 3 of 100, subtract log 3 of 18, subtract log 3 of 50. All right. The scheme pretty much is positive logs on top, negative logs on bottom. That's basically what the first two say. So this is going to be a log base 3, going to have a fraction. The 100 being positive stays on top. The 18 and the 50 being negatives go to the bottom, and they will multiply. And if you want to work this out, 50 goes into 100 twice. So that's going to be a log base 3 of a 2 over 18. Well, that reduces to a 1 over 9. Well, 9 is 3 squared. 1 over 3 squared. And that's going to be a log base 3, 3 to a negative 2. Finally, we get the cancellation we want. Works out a negative 2. All right, so they give you stuff with numbers there. In the next section, they have you bust up formulas. That's where algebra comes in. Page 395, but one like 47. Takes a log, and you have a big square root. You have an x squared add 4. And you are dividing by an x squared plus 1. And an x cubed subtract 7 quantity squared. Well, your square root is going to be a 1/2 log. And you still have all these same things. You have your x squared plus 4, x squared plus 1, and x cubed minus 7 squared. Remember, if you're on top, it's a positive log. On bottom, it's a negative log with a 1/2 as a coefficient. You have a log of the x squared plus 4 minus the log of the x squared plus 1 minus the log of your x cubed subtract 7 squared. And then finally, they like all powers down as coefficients. So this 2 is going to run down here. A 1/2 log of your x squared plus 4 log of your x squared plus 1. By the way, the directions on this were to expand. And minus twice log of x cubed minus 7. Okay. Why don't we try page 395. Let's try 53. Taking a 4 log of x, subtracting 1/3, a log of x squared plus 1. Add a 2. This looks familiar. I might have picked this out on Monday. I can't remember. Okay. Well, you're going to put your numbers up as powers. Log of x to the 4th minus log of your x squared plus 1 raised to 1/3, and add log of x minus 1 squared. Again, positives, logs on top, negative logs on bottom. Fractions here to combine. have your x to the fourth and an x minus 1 quantity squared. They're both positive, so they're top. And your x squared plus 1 raised to a 1/3 power, that's going to be on bottom. Negative. It's positive, and top here because it's positive. That's really the only system you really have to learn. And the very last kind of problems are, let's try problem 61. Log base 3 of 16, they want 6 decimal places. That's a little anal. All you really got to do is punch ln of 16 and scale it by ln of 3. See if we can write it down to 6 places. That's a little anal. ln 16, and we're going to divide it by ln of 3. 2.5237. That's 4 places. 19. 6 places. I won't, I'm not that anal about the rounding or anything, and I won't rip you on a true or false based on the places. We'll try to make it more obvious than that. Well, that's examples of all the problems we have in 4.3 and 4.4. So I'm going to go ahead and end the meeting, and I will hold the meeting at 9 p.m. tonight. So hope to see some of y'all there. Thank you.